Let's move into the third chapter of class 10th, which is pair of linear equation in two variables. In previous class, we have seen linear equation, two variables. However, we dealt with one linear equation of two variables. Here, we will deal with two linear equations in two variables together. In this video, we'll talk about intersecting, coincident, and parallel lines. In a short while, we come to know what are intersecting lines, what are coincident lines, and what are parallel lines generated through pair of linear equations in two variables. Here I have three sets of linear equations in two variables, x and y, x and y, x, y, x, y, x, y, x, y. Degree of all these equations, highest degree of all these equations is 1, so they are linear equations. Now, this one here, x minus 2y is equal to 0, 3x plus 4y is equal to 20. Now, if I write this equation, x minus 2y equal to 0 like this, minus 2y is equal to minus x, x goes this side, minus minus cancelled, y would be equal to 1 over 2, x or x over 2. Same operation I do with this one. This is 3x plus 4y equal to 20. 4y equals to 20 minus 3x. Y would be 20 minus 3x over 4. So I have this equation, I have this equation. Now, let's put some values of x in both the equations and get y values. I have these two equations here, x minus 2y is equal to 0, 3x minus 4y equals to 20. Now this equation gave me y is equal to x over 2, and this equation gave me y is equal to 20 minus 3x over 4. Now let's take some x values here, which will give me y value from this equation and y value from this equation. So these y values, I'll call them y1. These y values, I'll call them y2. Let's take some x values here. I have taken the smaller values 0, 1, 2, 3, 4, 5 for x. Now, in this equation here, I'll replace x with all these values, which will give me y values. If I replace x with 0, it will give me 0 over 2, which is 0. If I replace x with 1 here, it will give me y as 1 over 2, which is 0.5. When x is 1, y is 0.5. When x is 2, y is 1. When x is 3, y is 1.5. When x is 4, y is 2. When x is 5, y is 0.5. You can see here, this line started from here and grew up to this point here. Likewise, if I replace here x with all these values, I'll get some y values here from this equation. When x is 0, y2 is 5. I replace this x with 0, it will give me y as 5. 20 minus 3 into 0 is 0. 20 minus 0 is 0. 20 over 4 will give you 5. When x is 1, this y is 4.25. You can see this line, this orange line is for this y2 already started. X is 2, y is 3.5. X is 3, y is 2.75. Started from here, gradually it is growing. When x is 4, y is 2, y is 2. When x is 5, y is 1.25. So for these 5 x values, from this equation I got these y values. From the same x values, from this equation I got these y values. This blue line representing y1, this orange line representing these values, y2. Now, in this blue line and orange line, let's highlight some of the coordinates. I write the name of the equation on this blue line. This orange line here representing 3x minus 4y equals to 20. You can see this blue line and this orange line. Both these lines are intersecting at this point here, which is x is 4 and y is 2 here. I'll mention this point here where x is 4 and y is 2. So these kind of lines where both the lines are intersecting at some point, those type of lines are called intersecting lines. Now let's try to understand what do you mean by these intersecting lines, or what do we interpret by this point of intersection where these two lines are intersecting. We had these two equations, gave me intersecting lines, and the point of intersection was 4, 2, means x was 4 and y was 2. In these two equations, which gave me intersecting lines at these 2 points where x was 4 and y was 2, if I replace x in this equation here with 4 and y with 2, like this, x is 4 and y is 2, 4 minus 4 equals to 0. This is my left hand side and this is right hand side. Both are equal. Let's replace 4 and 2 in this equation also. 3 into 4 plus 4 into 2 equals to 20. 3 into 4 is 12. 4 into 2 is 8 equals 20. 20 equals to 20 means left hand side is equal to right hand side. Now the interpretation of intersecting lines. The point of intersection here, x is 4, y is 2. The value which we get is the unique value. 4 is the unique value for x, 2 is a unique value for y. Why do we call it unique is only x equal to 4 and y is equal to 2 will make my equation equal to left hand side and right hand side. Left hand side and right hand side. In this equation here, right hand side is 0. Here right hand side is 20. We wanted some value for x and y which can make this equation equal to right hand side which is 0. Same is applicable to this equation here. We wanted some value for x and y which can get me 20, which is the right hand side value, and the condition is in both the equations value for x and value for y should remain common. Means whatever value I keep here for x, same value I have to put here for x. Whatever value I put here for y, same value I have to put here for y also. These two are the values which I got from the point of intersection from those two intersecting lines. X equal to 4, y is equal to 2. These are the only two values which will make my equation equal to left hand side to right hand side, left hand side to right hand side. If you take any other value for x and y, those might equate left hand side and right hand side for one of the equations, but those same values will not equate second equation. Let's try with some other value of x. X is say 2 and y is 1. X minus 2y equals to 0. X is 2, y is 1. So 2 minus 2 equals to 0. This equation, left hand side is 0, right hand side is 0. Done. Let's try this with this equation. 3 into 2, 3 into x plus 4 into y, which is 1, equals to 20. 6 plus 4 is not equal to 20. So 10 is not equal to 20 means left hand side is not equal to right hand side. Means this value is not the unique value for this equation. That is why we look for the value which we get from the point of intersection from intersecting lines. Those values are the unique values which will make both the equations equal to left hand side and right hand side, left hand side and right hand side. Other than these two values, there is no other value which can equate left hand side and right hand side, left hand side and right hand side for both the equations together. Now let's try for this equation here. This will be 2y equals to 4 minus x. Y would be 4 minus x over 2. This one here would be 4y equals to 12 minus 2x. So y would be 12 minus 2x over 4. Question number 1. Question number 2. Y is equal to 4 minus x over 2. Y is equal to 12 minus 2x over 4. These two are the equations here. I have these x values here. I replace this x with these x values, which will get me y values. Okay. When x is 2, y is 1, x is 3, y is 0.5, x is 5, y is 0.5 negative. Now let's take these x values and put them here in place of x in this equation. Now I have these two lines, orange one representing y2, blue one representing y1. Now, in y1, in this blue line, when x is 0, y is 2. X is 0, y is 2 here. X is 1, y is 1.5. X is 1 here, y is 1.5. This point here. X is 2, y is 1. X is 2, y is 1. This point here. Likewise, when x is 5, y is negative 0.5. When x is 5 here, y is negative 0.5. This is negative 0.5. So x is 5, y is negative 0.5. Same as with this line. When x is 0, y is 3. The blue line is x plus 2y equal to 4. Orange line is 2x plus 4y equals to 12. Now, these two lines here, they are not intersecting. These two lines are parallel lines. Means, if you stretch both the lines on both the ends till whatever length you like, these two lines will never intersect. Now, what do you mean by these two parallel lines which we have got from these two equations? The blue one from this equation, the orange one from this equation. From these two equations, we got parallel lines. This equation gave me a line, this equation gave me a line. And both the lines from these two equations were parallel. So we call it parallel lines equation. Parallel lines equation. Now, since they were parallel lines, it means they will never touch each other, they will never cut each other. It means there will never be a common point for both these lines. Now, in case of intersecting lines, we had common points, x common for both the equations, y common for both the equations, which ultimately gave me left hand side equal to right hand side, left hand side equals to right hand side for both the equations. However, in case of parallel lines, since there is no common point, it means there will not be any common solution. Means there is no common value for x, there is no common value for y, which will equate left hand side equal to right hand side, left hand side equal to right hand side for both the equations. That's the interpretation of parallel lines. Means equations which gave me parallel lines do not have any common solution. Now let's look into this equation here. Now let's put this into this format. 3y equal to 9 minus 2x. So y is equal to 9 minus 2x over 3. And this will be y is equal to 18 minus 4x over 6. Same, I'll take some x values here. I have these x values. Let's replace this x here with these values and get some y values. 3 gave me 1 and till 5 I have these many values. Let's replace this x with these x values. X is 0, y is 3. X is 1, y is 2.33. X is 2, y is 1.67. You can see this is the orange line representing this y2. This line started at the same point where this line y1 started, the blue one, and running on the same line means orange line is running exactly on top of the blue line. Let's see, x is 3, y is 1. You can see my blue line has been completely covered by this orange line. Interpretation of this superimposing or both the lines sitting on top of each other is, we saw that these two equations or this pair of linear equation gave me coincident lines. Write it, coincident lines. Coincident lines means both the lines are running on top of each other or both the lines are superimposing each other. Means whatever value we got for y in this equation here, those values and whatever values we got here for y were same. You can see here for x value, y1 is 3, y2 is 3. For 1, which is x, y1, y2 all are same here. That's the reason this line here is coincident, or both the lines are superimposing each other. Now the reason for this to happen is, if you look at this equation here and this equation here, both the equations are actually same. If you multiply both sides of this equation by 2, you will get this equation here. 2x plus 3y multiplied by 2 gives you 4x plus 6y. 9 multiplied by 2 gives you 18. Or if you divide both the sides of this equation by 2, you will get this equation. 4x plus 6y divided by 2 gives you 2x plus 3y. 18 divided by 2 gives you 9. That is the reason behind these two equations giving you coincident lines. Now, coincident lines have all the points in common. Not like intersecting lines where only one point was common, or not like parallel lines where none of the points were common. Here all the points are common. Means whatever x and y value equates left hand side and right hand side of this equation, same value of x and y will equate left hand side and right hand side of this equation also. Other way around, whatever x and y value equate left hand side and right hand side of this equation, same x and y value will equate left hand side and right hand side of this equation also. And you know that in linear equation you can have n number of y values from given x values. Means all those pairs of x and y satisfying one of the equations will definitely be satisfying second equation. Means left hand side equals to right hand side, left hand side equals to right hand side. That's the interpretation of coincident lines.